All right, we are now live.
Awesome.
Cool.
Yeah, so Spencer, did you read Bart's comment on the discussion board?
Sorry, which one? Let me see.
What's the point of giving us a definition and then saying, "Oh, by the way, this definition is a pretty lousy one, but
Oh
we don't
yeah,
actually want to learn the real definition yet."
yeah, yep. For discrete,
Yeah,
yeah. I think it just means finite, like something that can be determined, something that
I
can
think
be.
they're referring to countable and uncountable infinities. But in the absence of further information, I'm forced to take the regular English definition of listable and say, well, it can't be written, or we
Hmm.
don't know it.
Yeah. I think what they're trying to get at is don't really worry about it. This is the definition, but we're not going to really cover it in this
Yeah.
class, so don't
As
worry
long as they
about it.
don't test us on it, I'm fine with that.
Exactly.
But if they do,
Yeah.
Yeah. Oh, just real quick. So we had someone else contact us about joining our group, and all I know about them is their email. So I sent them the link, and if they join, they join. If not, then you know,
Yeah.
tough.
yeah, I saw someone post asking what time it was, and
That was the one.
yeah.
So
Oh.
all right. Um, anything in part one that you wanted to go over?
No, I mean, I'm probably the weakest member in this group, but I read and did all the preparation. And I think I get everything. The thing that I'm struggling the most with is just like again the mean and discrete variable, but I think it's just gonna have to yeah, come down during this meeting. Plus, I'm gonna have to go back and look at it again.
Sure. So you have to be out of here by 4:30, right? 3:30.
Oh, me?
Yeah.
No, I'm not in a rush today, so
Oh, okay. Good. All right.
it's more, yeah. Yeah, what time do we want to be done by today? So we decided that before we start every meeting.
Let's not go past an hour.
Oh yeah.
I like that.
Okay. I don't think we'll use it either way. There wasn't a whole lot to go over.
Yeah.
So at least for me, the only way that I can figure out the Greek letters and the definitions is by actually building the table myself. So like for the four-sided die assignment.
Mm-hmm.
No, no, come back to me. So for the four-sided die assignment, I like actually built it myself, and the calculations on the far. Oh, this is backwards for you. On the far left, um, those ones I just did in Excel. But anyway, personally, that's how it helped me the most.
Yeah. Okay. Yeah, that's the one I was struggling with, so
I don't know if you guys have ever played Dungeons and Dragons or a tabletop role playing game like that.
I haven't.
I've always wanted to get into it, but never
Uh,
really known how.
I've played them a fair amount. I used to run games for Wizards of the Coast at Gen Con and run a bunch of other games. But so I'm used to the average distribution of hit points. So I was already familiar with the idea that the mean for each of those dies is between a number, 3.5, things like that.
Okay.
Yeah,
Awesome.
I think it's just the fact that there's not a zero. I am probably wrong, but I feel like if there's a zero, it might have landed on three
Hmm.
as an
Yeah.
option.
Do you guys go mind maybe going through question number 5 and just kind
Sure.
of help me with that one if you don't mind?
Yeah, no problem. We'll just use my screen and I still have wrong site, wrong patient open, so I'll just build it over to the side.
It's question 5. Randomly select a student in a class. What's the probability of selecting a student that is not from Utah or California?
No, in
Uh,
part 2.
from the
Sorry.
prep, from the
In the, from
preparation assignment.
Yeah, exactly. The
Right,
four-sided
that's the
die has
homework
four
assignment.
possible outcomes for each roll.
Yeah. Oh, well, that one you can start doing in your head because you have 4 numbers.
Mm-hmm.
So, no, see, I didn't button up my sleeves here because I didn't think you guys would be able to see it. You have 1 and 4
Yeah,
and
so
2 and
25.
3. And so they're both, you know, symmetrical. So the number in the center is 2.5.
Oh, okay.
So that's the mean. So the mean is really easy. And then to calculate the standard deviation, you have to do extra math.
Okay, gotcha. That makes sense.
Did you want to run through it?
Yeah, why not if we have time?
Mhm.
Sorry, it got a little funky.
Let me figure out how to post text here.
Yeah, hang out on air is awesome once you get used to all the features.
Yeah.
There we go. Chat. See if that basically did. See if you got the square root symbol in.
Awesome.
All right. So these are the titles of each of the columns to figure it out. Let's see. Let's do that. So X is just all the possible outcomes
Mm-hmm.
of rolling a four-sided die. So 1, 2, 3, 4. PX is
The value, right?
it's the probability of getting any certain outcome.
Mm-hmm.
So for 1, the probability of getting a 1 on a four-sided die would be 0.25.
Yeah.
Probability of getting 2 on a four-sided die is also 0.25. They're all 0.25, which consequently by the rule they all have to add up to 1, which they do. To get the variance, you multiply these two together.
Oh yeah, that's right.
Okay, and then this is your population mean. You're down at the bottom. That's
Excellent.
the funky Greek U symbol.
Mm-hmm.
But anyway, that's of note just because it's the population mean. So that's the answer for number 5 because that's what number 5 is asking for,
Mm-hmm.
the population mean. Number 6, however, asks you to finish the equation and find out the standard deviation. So this one's just a little bit of math. So let's see. X minus U. So for this line, X is the 1. Oops. Equals. Minus the population mean squared, so just times exactly the same thing. Times px, or your probability of that event occurring.
Mm-hmm.
Does that make sense? All that
It makes perfect sense. Yeah.
Okay. And Excel is really nice because it highlights the boxes as well.
Mm-hmm.
So if you're trying to find out where in the equation you are, you just click that one and go, oh, it's green. It's this one. So every separate box is a different color. Yeah, so then, oh, whoops, I need to grab this one, make sure it doesn't move. Whoops. And then just drag this down. Add all these guys together. Whoops.
Awesome. I get it now.
And that is your sample variance.
Once you
Cool.
add together, don't you have to divide by the number of things you were adding?
I think that's all done up in here. Because we're dealing with probability, the rules are a little bit different. So maybe I've figured out a different way, or maybe this only works with the one, but at least this is the answer that was listed in the answer key.
Okay.
So,
Would you mind shooting over that Excel to me so that then I could just sit and work on the formula? So
yeah,
that would be a great practice for me.
yeah, definitely. Let me just dump it into a new workbook.
Awesome. Thank you. You can do that
Yeah.
after. So it doesn't. I don't want to take too much time from this discussion, but I really appreciated that.
Yeah, no problem.
No, that's what we're here for, is to go over each of those questions like that.
Awesome.
Uh-oh. Something's not happy. Hmm. Okay.
There
That's
you
the
go.
correct answer. All right, so this is the example from part 5 and 6. Although, if you had anything else with 4 events and 4 probabilities, theoretically the formulas that are typed in should work. So maybe just kind of test them out, find a standard deviation calculator on the internet or something, and make sure
Yeah.
you can build it yourself. But
Awesome.
anyway. Did you get last week's stuff figured out?
Yeah, I think so. I need to, again, I had to spend some time practicing, but I think it's going to be fine. The material and all the resources are very good, so I just need to spend some time with it since this is my weakest subject.
Okay. Well, my offer, at least to help out, is still available.
I definitely appreciate that, and yeah, if you have time on Friday, that'd be great.
We'll figure it out.
Or yeah, anytime later in the week, basically.
Sounds good.
Awesome. Oh, I
So
see what you wrote
just
there.
to make sure, Spencer's the guy with the black headphones, and Marcus is the guy with the white headphones.
I'm
Yeah.
the really, I'm the really fat guy.
I'm the one with the Scandinavian accent, probably.
Alrighty.
Excellent. So should we jump into the group
Yeah,
meeting
thing will go.
quiz?
Mm-hmm.
Yeah.
Let's do that.
Alright, I just sent you the example, Marcus.
Awesome. Thanks, Spencer.
Alright, what class is this? 221.
Yeah, Math 221A. 11.
Yeah. Meeting.
And I know I can do the answers to the first 2 questions. It's true on both of them.
Oh, thank you.
You're welcome.
How kind of you.
I'll
All
grab
right.
the next one. Human blood can be classified into one of our basic types, O, A, B, and AB. Well, there's also negative, because I'm negative A. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Blood type, proportion. They define the blood types and the proportions given in the table above define a probability distribution. Yes, that's true. They do.
Assuming they add up to 1, which it looks like they do. Yeah, they do.
And
Yeah, it's
there are
correct.
negative types for people that lack those
There's
particular
positive and
proteins.
negatives. Yep,
Yeah.
there's positive and negatives. I'm O positive.
Just don't like feeling left out.
I think it was intentional.
I can take the
Alright.
next one then. What is the probability of a randomly selected person in the United States has a O blood around the 2 decimal places? So is it just
Just
you want a
0.45.
percentage? Yeah, exactly. Or 45%. I don't know how they want us to answer it.
Oh, I didn't read it, but at the top of number 3 it says give all your probability answers as decimals.
Oh yeah, that's right. Okay,
So,
0.45 then.
It says round to 2 decimal places.
Yeah.
That makes me nervous because there's only 2 decimal places.
hmm
Yeah, there might be more later though.
Yeah, maybe. I suppose it says that on all the questions. Okay.
Does that mean then? Okay. Question number 5. It's just 0.55 because it's all the ones that are not 45.
Correct.
Yes.
All right. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were
Oh my
trained to
goodness.
lie. They can do that actually. People
Really?
that have seizures frequently. There's a girl up at school last year. Dogs can, smell the chemical change in the body, like a minute early or something like that.
Yeah, when they
And
have their aura.
yeah, yeah, and
That's
and the dog would freak out, so the person would know it was going to happen imminently and get to a safe place, let people know things like that, and that way it didn't happen in the middle of the floor because I've seen that too.
hmm
Yeah, it's pretty
wow.
cool.
That's cool.
Anyway, the dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. Several bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. One of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dog guesses at random, what is the probability that they will correctly identify the dish containing the specimen from bladder cancer patient? Round to 3 decimal places. Is that just 167?
Yeah, 0.167. 1/6.
Wait, so it's basically just 1 out of 7?
1 out of 6. Because
Oh, 1
there's,
out of 6. Oh, sorry, I thought it was 7.
yeah.
Yeah.
Okay. Are we agreed?
Yeah.
Yep.
All right.
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer.
Correct.
I agree. Yeah, guessing correctly almost half the time.
Yeah.
Yeah. I mean, it's better
M&M.
than chance.
They're
30%
not
better
necessarily
than
very
chance,
good
but
at it,
yeah.
but yeah.
They're not going to replace a hospital anytime soon.
Yeah.
Then we got M&Ms are small chocolate candies. The M&M website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given the following table. And then that question is, if you reach into a bag of plain M&Ms, what's the probability of drawing a red-colored candy?
It's not exactly even. I knew it.
That's cool. So is it the answer just 0.13?
Yeah.
I wonder if that's the case in every bag, though, or if it mixes randomly.
I
If
think for the
the,
most part, yeah, it probably is.
Well, that's the distribution for every bag. So an individual bag might have a different
yeah.
distribution, but by and large, over time, that's going to be the
How do you measure
average distribution.
that? Open 1,000 M&M bags?
Well, they probably measure the ones they make. And so
Yeah.
they're like, oh, well, we made 50 million blue and we made 60 million orange or, whatever.
Yeah, that's true.
Machinery is also pretty impressive. It can measure just about anything. put in exactly 14 red ones and exactly whatever. Okay, so what is the probability that a randomly selected candy is green? All the other ones added up to 0.84, so that means that green is 0.16.
Excellent.
And the next question is how many are not green, so that's 0.84. The ACT scores of students admitted to a medium-sized public university in the western United States were taken from CapEx.com. The following summary statistics were calculated. Use the information to answer the question. Half of the observations are less than or equal to what? 24.3, because that's the mean.
Yep.
Well, no, I'm sorry, it would be the median. 24.
I thought it was the mean.
Because the mean is just the average. So if in a perfectly even symmetrical distribution, the mean will be the center. But apparently there are some outliers because the mean and the median are not identical. So when that happens, the median is the same thing as Q2. So every half of 50%, half of the observations will be less than or equal to the median.
Yep,
Okay.
you're right.
So 24.
Yep. Okay. Based on the information on the table above, the top 25% of the students scored above what number? So that's quartile 1, 22.
I think that would be quartile 3.
The
This is
27.
The top 25. Ooh, good catch. I was
Oh,
just
yeah,
thinking
27.
25%. Yeah, good catch.
Okay, and
Last
then
one,
which
too.
of...
Sorry?
Oh, sorry. I was just about to start the next question, but sorry, I interrupted
No,
you.
go ahead. No, go ahead.
Which of the following statements is not one of the 3 rules of probability? So the
second
top one.
We probably have different answers. Because the top one for me is the sum of the probabilities in any probability is 1.
That's what I have.
I think that's a rule.
Yeah, okay.
The long one looks suspicious to me. I don't think that's it. If the probability is high, then the probability is positive. The probability is low, then the probability is negative. You can't have a negative probability.
That's the one I was referring to. That was just my top alternative. That's
Okay.
why.
All right.
I don't think.
All right, I think
Are we
that's
good?
all the questions.
I think so.
Let's submit. What? We missed one.
Shoot.
Ah, darn it, we did.
The 3
Yeah,
decimal places.
Yeah, it is 0. I had Excel calculate it to 3 decimal places,
Yeah.
and that is correct.
Did they not want us to round, so it's supposed to be a 6 instead of a 7 or something ridiculous?
I don't know. Let's email the instructor about it.
Huh. Yeah, Bart, you wanna send that email then?
Sure.
So you can correct it for all of us.
Number
So,
6.
look up our instructor's name for this class. Okay.
Yeah, you never know the name of a online professor.
I remember for my C++ classes, because I have to write their name at the top of every assignment so the computer will process it properly.
Oh, okay.
Well, excellent.
All right. Anything else?
I don't think
That's
so.
everything.
Thanks for taking time with me in the beginning. It all made sense now.
That's what this is for. Cool.
Fantastic.
All right. Well, I am free until 5 my time. So 5 p.m. my time. So for the next 9.5 hours, if you wanted to just send me an email.
Awesome. Will do.
Cool.
I'm going to work on the 5th assignment there again on the answer key and look at your Excel document, and if I don't get it, I'll definitely hit you up.
Okay. All right.
Awesome.
Thanks, everybody.
All right.
Thank you, guys.
Thanks. You guys
Bye.
have a great day.
You
Bye.
too. Enjoy the morning.